So we're going to talk about exponential function, the graph of it, and their transformation. So in our first example, we have 2 to the power of x. So what I mean by exponential function is when our variable x is in the form of the exponent. So that's why it's called exponential function. And another reason why it's called exponential function is when you look at this graph, if I zoom out, you can see that from 0 to 5, that the graph increase dramatically at a high exponential rate. So you see, it's not going diagonally like a normal linear rate, but here is increasing at a high exponential rate. So that's why it's called an exponential function. But we are just going to talk about the graph of it and its transformation. So when it's 2 to the power of x, we see that the y-intercept is at 0, 1. Now, if you were to look at the left side of the graph, it looked like it's touching the x-axis, but if I were to zoom in, you can see there's little spaces here. And then I keep going to the left, you still see little spaces there. So what it means is that the graph of this exponential function will go near the x-axis, but will never cross it. So if I were to talk about domain and range, here it's continuously going to the left. Now, this is Desmo, so it won't show you the arrows, but any given graph on paper, it will show you arrows saying that it's continuous. So it's going continuously to the left, and over here, it's continuously going up and right. So if we were to talk about domain, left and right, so it would be starting from the left side, negative infinity, all the way to the right side, which is positive infinity. Now again, the graph will never cross the x-axis. So if I were to talk about the range, the lowest value of, or I could say the bottom of this graph would be 0 with a parenthesis, not a bracket, because again, this graph will not touch nor cross the x-axis. So 0 will be parenthesis instead of bracket. Now it's going upward, so that means that it's continuously going to positive infinity since it's going upward. Now, if I were to do with different bases, so in this example, our base is 2. The second example, base of 3, is pretty much the same thing. The graph is going near the x-axis but will not cross it. And the same thing is going upward to positive infinity. So I would say that the domain and range would be the same regardless of the base. Same thing if the base was 7. So here's a graph of with base 7. So 7 to the power of x. You can see that if I were to zoom in really close, there's little spaces between the graph and the x-axis. So again, with all these 3 graphs that I've shown, they're all going upward at an exponential rate. So to positive infinity for the range, and then positive infinity for the domain of the upside and the right side. Now, what's in common with all 3 of these graphs is that they all have the y-intercept at 1. Now, keep in mind, with exponential functions, our bases cannot be 1 nor 0, because whatever exponents you have, if for the base of 1, it's always going to be 1. Same thing with 0. So for exponential function, you will not see one where the base is 1 nor 0. But here, any function that you have, any exponential function you have, the y-intercept will always be 0 if there were no transformation. Right here, there's no transformation if you look at the 3 on the left side. Now, how we get that? Well, if x is 0, and you plug into 0 here into x, so it means 2 to the 0 power. So 2 to the 0 power is 1. Same thing with 3 to the 0 power, also 1. 7 to the 0 power, also 1. So anything power to the 0 will equal to 1. Now, let's talk about transformation. So here is the graph of 2 to the x power. Now, if we decide to add a 3 to the x only, meaning that 3 is part of the exponent, what would happen? So if I zoom out, the orange graph is 2 to the power of x plus 3. And we see that the graph shifted to the left. Now, if we were to compare with the y-intercept, here's 0 to 1. Now, if I were to click on this one, I see that it moved 3 units to the left, which is why it's negative 3, 1. It has the same y value but different x values. So the difference is between 0 and negative 3 is that it only moved 3 units to the left. So it's pretty similar to the transformation we did before in 1.5. Now, what happened if in the x, it's x minus 4? So if x plus 3 means 3 units to the left, we can safely say that since it's opposite, 4 units to the right. So let's see. So we see that the purple graph, 2 to the power of x minus 4, it did indeed move to the right. And if I were to compare with the y-intercept, so here, 0, 1, and then here, 4, 1. So the y value stayed the same, but the x value changed by 4 units. So again, if there's a number with the x, we can see that it shifted either to the left or the right. So if it's plus with a number, it means to the left. If it's minus, then it's going to go to the right. Now, let's talk about when there's a number after 2 to the power of x, meaning that this 1 right here in this example is not part of x, it's just after the function. So basically, let's check it out. We see that the graph moved up by 1 unit. So if I zoom in, here's 1 and here's 2. So 2 to the power of x plus 1, we can see that it shifted 1 unit up. So if I check the y-intercept, 0, 1, and then here, 0, 2. So the x value stayed the same, but the y value changed by 1 unit. So if there's a number adding to the function, so after the x, after 2 to the power of x, if it's adding, it's going to go up. What about if it's subtracting? So if I zoom out, it's 2 to the x power minus 5. What's going to happen? Well, we see that it went down. So it shifted 5 units down. If you take a closer look, so here's 1. And if we were to compare with the y-intercepts, so if we were to check 1, 2, 3, 4, 5 units. So there is a correlation. So if it's minus 5, meaning that if there's a minus after the exponential function to the power of x, it's going to shift down. So here in this example, minus 5 means 5 units down. So let's see what happens when there's two transformations, meaning if there's a number with the x and then another number after the x outside the exponential function. So 2 to the power of x minus 1 and then plus 3. So if it's with the x, that means it's either going left or right. If it's after the x outside, then it's going to be either up or down. Now, since it's x minus 1, if we compare with the previous example, it means to the left. And in here, if it's outside the function after the x, since it's plus, it means up. So let's take a look. So we do see that the graph did move up, and we were taking a look at the numbers. So it went up 3 units, and it also shifted to 1 unit to the right. Now, if I were to move up a bit, you see that the graph did move to the right. Now, you can't see it well, but if we were to compare it with coordinate points, then sure, we can see the difference. So again, 2 to the power of x of minus 1, that means moving 1 unit to the right, and then plus 3, meaning 3 units up. So that's pretty much about translations, up, down, left, right. Now, let's see what happened if there was a negative on the x. Is it the same as what we did in 1.5? So we see that there was a negative on the x only. We see that the graph flipped or reflected across the y-axis. So it's pretty much the same as what we've seen for 1.5. So if there's a negative on just the x of the exponent, then it will reflect over the y-axis or flip over the y-axis. Now, say that we do still have the negative on the x, but also it's now 2 to the power of negative of x plus 3. So this time we have a plus 3 with the x. So what's going to happen? So let me bring back the other graph. So the green one is the one that was being reflected because it has a negative on x. But what happened is when it's negative, parenthesis x plus 3, close parenthesis. If we were to compare it with the green graph and the orange graph, we see that they both reflected over the y-axis compared to the red graph. But between the green and the orange, we see that the orange moved 3 units to the left. So if I were to go in here, so this is negative 1, 2, and then this is negative 4, 2. So the y value stayed the same, but the x did not. The change between negative 4 and negative 1 was 3 units. So the green graph, in order to be the orange graph, it shifted 3 units to the left. Now, again, let's compare with the green graph that's being reflected and compare it with this graph. All right, so here's the purple graph. 4, 2 to the power of negative of x minus 4 plus 1. So we see that it's x minus 4. That means that it's going to the right 4 units, but also being reflected. As you can see, the green and the purple graph, you can see that they both reflected over the y-axis. Now, minus 4 with the x, meaning it went to the 4 units to the right. So we can see that, yes, it did move to the right. Since it's minus 4, it means shifted 4 units to the right. Now, since there's a plus 1 after the x, that means that it shifted 1 unit up. So if I were to compare on the right side, we can see that the green graph to the power of negative x to the purple graph, where it's plus 1, yes, it did indeed shifted 1 unit up. All right, let's go back to the origin. Now, same thing. 2 to the power of negative of x plus 2. Instead of minus 4, we have plus 2. So if we have plus 2, it seems that it's going to be the same as the other transformation, meaning since it's plus 2, it's going to be 2 units to the left. But we also have a minus 3 after the x. So if the plus 1 in the previous graph, previous example, mean up 1, we could say that it's going to be in the opposite direction, down 3. So checking this graph, plus 2 mean to the left, 2 units, and then minus 3 after the x, 3 units down. So here we can see that it did indeed move downward, shifted 3 units down. And then we can see from here that it did indeed shifted to the left by 2 units. So pretty much the same transformation as before. If the number is with the x, it's going to be left or right. If it's after the x, it's going to be up or down. This time, it has a negative outside on the x, so that means it's going to be a reflection over the y-axis. So again, to review with this example, 2 to the power of negative of x plus 2 and then minus 3. Plus 2 meaning that it shifted 2 units to the left, and then the minus 3, it went down 3 units. All right, now, let's compare with the original function, 2 to the power of x. Now, if we were to look at the example, negative 2 to the power of x, what would be the difference? Well, it's a blue graph. And if I were to compare the red graph versus the blue graph, I see that it flipped. So it flipped over the x-axis. So it reflected over the x-axis. So what it means is that if our base has a negative, or just like in 1.5, if there's a negative outside a function, then that means that it's going to be reflected across or flip over the x-axis. So let's compare with examples. Now this one, it has a negative on the base, meaning negative outside a function, but it also has a minus 5 on the x, and then a plus 1. So if we were to compare with the graph, here there were no transformation. The red graph, 2 to the power of x, there were no transformation. But since there's a negative outside a function, we see that it flips or reflected across the x-axis, but it also shifted 5 units to the right because there's the minus 5 with the x. So x minus 5 means shifted 5 units to the right, and then it shifted 1 unit up. So there's a plus 1 after the x. So plus 1 means 1 unit up. Now, this one seems similar to the last example. So there's a negative outside the function, or a negative on the base. So we can say that it's going to reflect it over the x-axis, which it did. See how it's going downward? So yes, it did reflect it across or over the x-axis. Now, plus 2. So it's the same as all the examples we discussed. So plus 2 meaning that it's going to shift 2 units to the left. So if we were to compare with the y-axis here, it did shift it 2 units to the left. And then pretty much the same as the other examples, if there's a number after the x, meaning outside that parenthesis, so minus 1 or plus 1, minus 3, plus 1. So if it's minus 1, that means that it's going to shift 1 unit down. And if we checked, yes, it did go down. Now if I were to zoom in closely, this is 1 unit down. But to zoom out to see a bigger picture, it reflected across the x-axis, shifted 2 units to the left, and then 1 unit down. So it pretty much has the same characteristic of the transformation from 1.5. So let's review. If there's a number with the x and the exponent, it's going to go either to the left or to the right. Now if there's a number after dx, big as the base, so plus 1 minus 5, that means that it's either going to go up or down. Now if we have a negative on the x, the exponent, then it's going to reflect across the y-axis. Same as all the other examples here. Reflected across the y-axis. Again, if there's a negative on just the x. Now, if there's a negative on the base or negative outside the function, they're all reflected across the x-axis. So pretty similar to the transformation from 1.5.